In this video, I'm going to show you how to use the C++ Numerics Library function iota to generate interesting sequences. I'll start with showing the basic example of how we can use iota to fill out a vector with increasing values, and then we'll do a more interesting example where we generate a sequence known as the triangular numbers. Let's just look at the documentation for iota real quickly. We see that iota requires 3 input parameters. First two are iterators to the first and last elements in some container. In our example, the container is going to be a vector of integers. And the last input parameter is a value, in our case of type int, which is the initial value to store and from which all other values will increment and be generated. So let's go to Visual Studio and do a very simple example. So here I have a console app set up. I've also added a function to print a vector to the console so that we can see the values that we're going to be printing out. But let's just create a vector called v of type integer. And we'll give it 10 values. And let's say we wanted to start at 1 and have our values in this vector be all the integers from 1 to 10. It's very simple to use iota to do this. First thing we have to do is include the numeric header. And then we can call std iota. And we're just going to give it the begin and end iterators of v. And we want our initial value to be 1. And now we'll print out the vector v to see what its values look like. And there we go. Our vector v has values starting at 1 and counting all the way up to 10. Now we can change some things up. We could say let this vector have 20 elements and let's let the starting number be 17. Then we'd be starting at 17 and ending at, I think, 36, which would be 20 values after 17. And there they are, 17 to 36. So the key to iota is how many elements are in your vector. In this example, there's 20. And what's your starting value? In this case, 17. And if you just use iota in that basic way, you're going to get an increasing sequence of integers, starting at your initial value and counting up to as many values as you have in your vector. Very nice, very easy, very simple to use, and very useful actually. But now I want to do a more exciting example. I want to generate what are called the triangular numbers. So here's a Wikipedia article detailing the triangular numbers. You can see that the triangular numbers get their name from the fact that the values of the numbers can be arranged into triangles. For example, this triangle has 3 dots, this one has 6, this one has 10, 15, etc. And those are exactly the numbers in the triangular number sequence, 0, 1, 3, 6, 10, 15, 21, etc. And the way these numbers are generated are by adding one more each time between the numbers. For example, from 0 to 1, you add 1. To get from 1 to 3, you add 2. To get from 3 to 6, you add 3. To get from 6 to 10, you add 4. To get from 10 to 15, you add 5, and so on. So each time we're adding one more number to generate the next number in the list. So the question then becomes, how can we use iota to generate the triangular numbers, or any fun sequence that we want to generate? And the answer lies in understanding the third parameter of iota, which is the initial value. The type t and the value have a few rules about them. And you can see it in this little description we have on the iota page. It says if any of the following conditions is satisfied, the program is ill-formed. T is not convertible to the value type of forward iterator. So in our case, if t would not be convertible to an int, or if the expression plus plus val is ill-formed, or val is a variable of type t. So in other words, if we want to have a program that is not ill-formed, one that works nicely, t has to be convertible to our value type, which is integer, and we have to have a plus plus operator that works nicely. So let's write a class that's convertible to int and has a plus plus operator, and we'll use that class as a generator for triangular numbers. I'm going to call this class triangular number generator. And there's two things I want to keep track of in this class. The first is the actual value that we're on while we're generating it, whether it's 0, 1, 3, 6, 10, etc. And the other is which number we're adding next. So for example, if I'm at 6, I want to know how much I need to add to get the next number. But I know that that number increases by 1 each time. For example, here I'm adding 1, then 2, then 3, then 4, then 5. So I'm going to have two member variables in this class. The first I'm going to call value, and the second I'm going to call num to add. And the initial value is 0, and the number we want to add first is going to be 1. You can see that because we're starting at 0 and then I'm adding 1 to get to 1. Now in order to make this generator usable in iota, it has to be convertible to int. So I'm going to create a operator overload for type int, which is simply going to return value. And the other operator we needed to have was the increment or the plus plus operator. So that returns a reference to an int. And the information on the syntax for these operators is available at CPP reference, and I will be making videos on how to do operator overloading as well. But it's in this increment operator that I'm going to generate the triangular numbers. And here's how we're going to do it. We're going to take our current value and add the num to add. For example, if our current value is 0, we're going to add 1, and then it would be equal to 1. But then we need to increment the num to add because it goes up by 1 every single time. And then I'm going to return mValue because iota always increments, and then whatever the value is after the increment, it gets added into the vector. But you can see if value is 0, we're going to add 1, the num to add bumps up to 2. If our value is 1, we're going to add 2 and get 3. The num to add goes up to 3. 3 to 6, then the num to add becomes 4. 6 plus 4 is 10. Num to add becomes 5, etc. And originally we had 17 as the value parameter for iota, but instead I'm just going to copy triangular number generator, and I'm going to construct it right as the third parameter in iota. And you can see it doesn't yell at me because triangular number generator is convertible to int. So as far as iota knows, this is just an int, and it has a plus plus, and it's going to spit out another int. And that's all iota needs to know. So let's run this and see what happens. And here we are. You can see we have the triangular numbers as laid out in Wikipedia. 0, 1, 3, 6, 10, 15, 21, 28. 0, 1, 3, 6, 10, 15, 20, and 28. This is the triangular numbers. So we used iota to generate these by creating a custom class that simply had a conversion to int and an increment operator. And using that fact, you can generate any kind of cool sequences you want to with std iota. So thanks for watching this video. I hope you found it useful. Have a good day.